Hi, I'm Ollie, with over 7 years of experience working in top tech companies such as Amazon and Goldman Sachs. I'm here to help you level up your coding skills and land your dream job in big tech. On this channel, LeetCode LevelUp, I'll be posting daily videos to guide you through solving coding challenges and becoming a better programmer. If you enjoy the content, don't forget to hit like and subscribe and stay tuned for more. Today we're going to be looking at LeetCode question 121, best time to buy and sell stock. You're given an array prices where prices I is a price of a given stock on the ith day. You want to maximise your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. Example 1. Here are the prices, and it's going to look something kind of like this. The output is going to be 5, where you buy 1 and you sell at 6. Example 2. Here are the input prices, and it's going to look kind of like this, which is just a downward trend where there's no opportunity to make a profit, so you return 0. The approach that we're going to be taking is using dynamic programming, with a time complexity of O of n and a space complexity of O of 1. Now let's walk through. Here are the prices that we're going to be looking at. We're going to iterate over them starting at 10. We're going to declare two variables, max profit, we'll set it equal to 0, and we'll calculate max profit, the maximum of current value minus the minimum value, or the maximum profit that we've observed so far. The minimum value is going to equal 10, which is the first observed price. So we then go to the next item in the array, we update the minimum value and set it equal to 7, and then we go to the next price in the array, which is 8. So we update the maximum profit to 1, we go to the next price, which is 6, we update the minimum value to 6, and then we go to the next price, which is 9. We update the maximum profit and set it equal to 3, we go to the next item in the array, we then update the minimum value to 5, and we go to the final item in the array, which is a price of 6. Okay, so we've come to the end of the array, and now we return 3, which is the max profit. And that's obtained by buying at 6 and selling at 9. Great, thank you very much for watching, and I hope that this has clarified this question for you. It's as easy as that. Why not pause the video and try to implement a solution yourself? If not, stay tuned for my solution next. So now we're going to solve question 121, best time to buy and sell a stock. So we're told that we've been given an array of prices where price I is the price of a given stock on the ith day. You want to maximise your profit by choosing a single day to buy one stock and choosing a different day in the future to sell it. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. So I think one of the first things that I'd be asking in this scenario is, are we always getting an input? Will we always have at least a single price? So that's what I'd ask the interviewer. It'd be first question. It often is when I'm working with arrays. Second would be, can we have negative prices? Obviously a stock or whatever underlying asset cannot have a negative price as far as I'm aware. So that would be something that I would just show a little bit of knowledge that I understand that prices tend not to be negative. So that would be the sort of two main edge cases that I'd be sort of asking the interviewer about. If you followed along with the whiteboard walkthrough, then you should hopefully have a solution for this. So let's get started. So first let's set the current low or max low. I'll say current low equal to prices 0, and I will set max profit equal to 0. Then for loop over each of the prices, let I equal 0, I is less than prices dot length, and I plus plus. Okay, and then we're going to use math. Well, we'll set current low equal to math dot min, and we'll check if current low is smaller than price, the current price I. Okay, so this way we're keeping track of what's the sort of the lowest number that we've seen, which is part of what makes this dynamic programming. And then the max profit, we need to see what am I doing here? Max profit equals math dot max, and we'll see what's bigger. Is the current max profit bigger, or is our current price, which is prices I minus the current low? Okay, then finally we return the max profit and see if that runs. No. Okay, what's up with that? Oh, what am I doing? There we go. That should now run. Okay, cool. Let's see how we do in terms of submitting it. Will it pass the tests? Cool. Okay, so in terms of runtime, it's top 79.15%, so it's pretty good. And it beat 79.04 in memory, so it's a pretty good answer, I think. That the runtime complexity is O of n, because you've got to iterate over every input, and the space complexity is O of 1 constant. Well, thank you very much for watching. If you like the video, please click like, click subscribe if you want to see more, and then if you have any feedback or anything that you'd like me to produce, then please leave a comment below.